subscribe this educational channel, so please subscribe and don't forget to put in the bell icon and stay updated with our new videos.
Let us study Newton's second law of motion. Part 1. The rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. Let us understand the mathematical formulation of this law. Consider an object of mass m moving along a straight line with an initial velocity u. The initial momentum of this object will be mu. Suppose a force F acts on this object for time t, and the object uniformly accelerates to velocity v. That is, the final velocity of the object becomes v. Thus, the final momentum of this object will be mv. Now, according to Newton's second law of motion, force is directly proportional to change in momentum upon time taken. So, F is directly proportional to mv minus mu upon t, where mv minus mu is the change in momentum. Therefore, F is directly proportional to m into v minus u upon t. But v minus u upon t represents change in velocity with time, which is known as acceleration. Hence, we get F is directly proportional to m into a. Thus, the force acting on an object is directly proportional to the product of mass of the object and acceleration produced in the object. Thus, we can write F is equal to k into m into a, where k is the constant of proportionality. We know that SI unit of mass is kilogram, and that of acceleration is meter per second square. The unit of force is so chosen that the value of the constant k becomes 1. For this, 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kilogram mass. That is, 1 unit of force is equal to k into 1 kilogram into 1 meter per second square. Thus the value of k becomes 1 from equation 1. We can write F is equal to m into a. Thus, force acting on an object is the product of its mass and acceleration. Second law of motion, part 2. We use second law of motion in our everyday life. For example, a cricket fielder, while catching a fast-moving cricket ball, gradually pulls his hands backwards with the moving ball. This action of the fielder increases the time taken to decrease the high velocity of the moving ball to 0. Due to more time taken to stop the ball, the rate of change of momentum of the ball is decreased, and hence, a small force is exerted on the hands of player. However, if the ball is stopped suddenly, the time taken to decrease the high velocity of the ball to 0 is very small. Due to this, the rate of change of momentum of the ball will be very large. Hence, it will exert a large force on players' palms, and may get hurt. Also, in a high jump athletic event, the athletes are made to fall on a cushioned or a sand bed. This increases the time taken by the athlete to stop after the high jump, and decreases the rate of change of momentum, and hence the force of impact. The mathematical expression for the second law of motion is F is equal to m into a. The first law of motion can be mathematically stated from this equation as F is equal to m into v minus u upon t, or Ft is equal to mv minus mu. If F is equal to 0, then 0 is equal to mv minus mu. Thus, mv is equal to mu. Cancelling m from both sides, we get v is equal to u for whatever time t is taken. This means that the object will continue to move with uniform velocity u throughout the time t, if no external force acts on it. Also, if u is 0, then v will also be 0. That is, the object will remain at rest unless an external unbalanced force acts on it.
Tell me pretty lies, look me in